Today I will learn about time complexity, algorithm efficiency, and then complex complexity, and then iterators and generators. So this is today I will my learn about time. This is my time block, morning time block for AI engineering. I'm Schweiber and I'm in journey of being AI engineer. Thank you. So first of all, I have to learn time complexity and algorithm efficiency. Okay. Mm. First, I try to understand time complexity. What is time complexity? Time complexity describe how the runtime of an algorithm grows as the input size increases. That means what I came to learn, like when anyone write an algorithm, when the input size of the algorithm is increases, how runtime increase accordingly. So this is the time complexity. We use big O notation for express this big O notation. Okay. What is big O on big O notation? So big O notation describe the worst case scenario for how long an algorithm takes. So when anyone try to build something, he has to think about worst case scenario, right? So he has to implement such a way or make the algorithm such a way so that it can handle the worst case scenario, right? So there are some common time complexities. First one is constant time, and there are some example as well. Accessing an implement in a list by index, operations that take same time regardless of input size. That means whatever input size it will, then it always takes the constant time, same time. And we can see in the code in action there is a function get first element, and it takes the list, take a list, and it return the first element of the list. So in that case, if we think a list of like 10 elements, and it can be 10 thousands of elements of list, so always it takes the same time to return the first element, or not only first element, it can be like whatever index it can be. Okay, so this is the constant time. I got it, the constant time. Okay, fine. Then then logarithmic time. So what is logarithmic time? There are two example there. One is binary search and operation that divide the problem in half each time. So suppose this is the whole thing. First half this thing, and then half this thing, like that. So it takes the logarithmic time. So there is a code in action binary search function. Let's see, break down the binary search function, how it works. Okay. So first there are defining two they define two variable, left and right. Left is 0 and right is length of array minus 1. That means this is index. Okay, so left index will be 0 and right index will be last index of the array. So that's why it it assign length of array minus 1. Okay, then there is a while loop. While left is less than equal right. Okay, while left first of all it defines two variable left and right, and then then it runs a while loop, and first it assign a mid. There is another variable that is mid, that means middle, left and right and middle, that's it. So middle is equal to left plus right, floor division by 2. Okay, floor division by 2. Okay, fine. Then if array of mid is equal to target, then it's fine, return the mid. And else if array of mid is less than target, then what it will do, it will do the left is equal to mid plus 1. Okay, so it will do mid plus 1. Other than that, it just assign a new value of right, that is mid minus 1. Okay, and that's it, that's the thing. So if I try to code in action, make a new file, that is time complexity dot py. Okay, fine. So define what is it called, binary search. First it take array and then it take target, and first left and right equal to 0, and length of array minus 1. Okay, that's fine. Then it run a while loop, and until it less than equal right, left is less than equal right, it will loop over the loop over. Then first it assign a variable of mid, and that will be left plus right, floor division by 2. Okay, after that I have to check array of mid, index number mid equal to target, then immediately return the mid. Okay, we find the index or value. Else if array of mid less than equal target, then we have to assign a new value of left, that is mid plus 1. Else right will be mid minus 1. Okay, and finally return minus 1. If I somehow we don't get any value from that while loop, then it will just return minus 1, as it seems like there is something error or something like that. And so if that's why I finally return minus 1. So when I get the minus ones somehow, so that I can know that there is something error, something like that. Otherwise minus 1, there is no possibility to getting minus 1, right? There is no minus 1 index of an array. Okay, so what it does, I should apply the binary search of something like that. First, this is array, and second, this is the target. So if I print it and then try to run it, then it gets the 2. Okay, it print the true 2. How it get it print the true? Let's see. So this is our array, and this is the target, right? So first of all, it assign left and right. So left is equal to 0, that means 1, and right is equal to 5. Last index. And then it runs while loop, left less than equal to right. Yes, first of all, okay, I'm just okay. So first it assign left equal to 0 and right equal to 0 1 2 3 4. Okay, 4. And then it runs while loop, and yes, left less than equal to right, it match that condition. So first, then it assign the mid value, and that will be 0 plus 4 divided by floor division by 2, that means 2. Okay, so 2. Then if array of 2, that means 0 1 2, that means 3. So first if is met its target, right? So array of 2 is equal to 3, and our target is equal to 3. That means we met our condition and return mid. The mid was 2, so that's how it prints the 2. Okay, and I again another like binary search, and that is gonna be 4, let's say. So how it okay, first it assign left is equal to 0, right is equal to 4. Then it goes over the while loop, and first it assign mid of what? Mid is equal to 2. Yeah, and then first thing, array of mid, that means array of index of 2 is equal to 3. That is not matched our target, so it goes to ellipse section, and 3 is less than target. Yes, so 3 is less than 4, that's why it made that, and it assign a new value of left is equal to mid plus 1, that means 3. Okay, okay, and then it goes over there in the top section. So in the top again it assign mid is equal to left plus right. So again it goes to while loop, and mid is equal to now left 3, and right is equal to 4, that means 7. Floor division by 2, that means 3. Okay, and mid is equal to 3, it's okay. Okay, for better understanding, I rewrite the current current value of right, that is 4. So 3 plus 4 is equal to 7. 4 division by 2 is equal to 3. That means mid is equal to 3. Then if array, I go to this condition, if condition, and array of 3, that means 0 1 2 3, that is 4. 4 is equal to target. That means in that case we got our return value, that is 3. And if I run that, yes, I got the value 3, right? So this is how binary search work. Okay, fine, we go to our thing. Sorry, yeah, got it. So then we go to linear time. There are another time complexity, that is linear time. Iterating through a list, when it happens, like iterating through a list or operation that process each element once. Yes, each elements once, then the linear time complexity is happen. We see a code in action, that is find max function. It takes a list and max value. First of all, it define a variable, that is max value, that is initially first element of the list, and then it runs a for loop over the list. And then inside the for loop we see there is if condition. It again and again it check. So first number is max value greater than max value, then max value variable will assign by the number, and again. So it has to iterate over whole list. Okay, so if I think like the list, if the list is contains like 5 elements, so it iterate over 5 times. Okay, and if it contains like 50,000, then it has to iterate over 50,000. So that's why it is a linear time. Okay, so the curve is bam. The input, how input grows, the runtime grows accordingly, same way. That's the linear time. Okay, and then the linear rhythmic time. So n log of n, logarithm of n. And the example of these things is efficient sorting algorithms, for example merge sort, quick sort, something like that. So it uses in sorting system, sorting algorithms. And that is that, and this is sorted function. And if, okay, so there is no in description or explanation or a custom function for that. It is just using sorted function like this, print of like sorted list of something like that. So sorted is offered by Python language, so that is inbuilt function. If I print it, we can see it is sorted over there, 1 2 3 4 5. Okay, so it uses the linear rhythmic times. But we should know about more, like linear rhythmic time. So we should go ChatGPT or Claude New and search over linear rhythmic time. And I say Claude that you are my instructor of let's say programming. Teach me logarithmic time complexity in very easy way. Let's see how Claude teach me. Okay. Okay, first in piece 0 of n, that is linear time. If you have n times, then and touch each one once, that's n steps. Double the time items, double the work. Okay, I got it. The last thing and then 0 of log of n, that means logarithmic. And logarithmic times is this happens when you keep cutting the problem in half step. Okay, it also I just learned. And searching a phone book by repeatedly opening it to the middle of the class. Example, thousands of names doesn't take thousands of checks. Okay, so it takes about 10, since 2 times of 2 power of 10 is equal to 1000. Okay, that's the case. So to check 1000 items, we have to check just 10 times. Now combine of them, 0 of n and 0 of logarithm of n, then it comes to linear rhythmic. Okay, fine, do a log of n amount of work, but for every single item of n. Got it? Do a logarithm of n amount of work for every single item. Think of it as n multiplication of logarithm of n. The everyday picture. Imagine you have a messy stack of 1000 exam papers to sort by name. A slow approach is gonna be compare every paper to every other paper. That's roughly n into n. That means n big O of n square. That means quadratic time complexity. It's very slow. Yeah. A smart approach will be split the stack in half, sort each half, then merge them back together. Yeah, that's really amazing. That's true. That's true. If I think about it in real life, like what it gives me an example, like thousands of paper of sheet, and I have to short it over thing over all, and then if I each time I have to split in half and merge them together. That take a very small of time. Okay, yeah, this is how literally how merge sort works. Okay, so here's why that gives you n logarithm of n. The logarithm of n part, you keep splitting the pile in half again and again until each pile has just one paper. Okay, if you have 1000 papers, you only need about logarithm of base of 2 and 1000. Okay, 10 logarithm base 2 of 1000. What does it operator is called, I don't know. Anyway, 10 levels of splitting. The n part is at every single level of splitting. Okay, I got it. So every n level of splitting, that means suppose there are 10 what I can say, there are 10 documents, and I have to split in two half, right? So now the n is 2. So I have to do the logarithm of n for first one and then again for second one. There's the quiz. There's it talks about. Okay, I got it. So 10 levels into 10,000 papers per level. Hmm. Then is equal 1000 papers per level, that is equal to 10,000 operation. Instead of 1000 into 1000, that is 10 lakh 10 lakh operation for the slow way. I have just to take 10,000 operation. That's that's the n of logarithm of n. That means linear rhythmic time complexity. So that's the magic of O of n logarithm of n. It's a way faster than O of n square, but a bit slower plan than plan O of n. Yeah, where you will see it like merge sort, split array in half, logarithm of n levels, merge in elements at each level, and then quick sort, average case, same splitting idea, and heap sort builds or maintains a heap for n elements. Any divide solve combines algorithm, like splitting is equal to logarithm of n, combining is equal to n. Okay, and visual growth comparison for n is equal to 1000, O of n is equal to 10,000. Yeah, I got it. And n logarithm of n is equal to 10,000, and n square is equal to 10 lakh steps. Okay, so O of n logarithm is comfortably between fast and slow. Yeah, it's the sweet spot most good sorting algorithm aim for. Okay, and quick mental rule is whenever you see an algorithm that splits work in half repeatedly, logarithm of n, and it still has to process every element at each split level of n, it's O of n logarithm of n. Okay. So what I have learned, that is, when I see I have to split I have to split, and I have when I split in two, let's say, and again I have to split for those two, so again I have to split it and also it. So then the time complexity for that operation is going to be n logarithm of n. That means linear rhythmic time complexity. Okay, fine. Okay, then is n square, that means quadratic time complexity. That means nested loops, or like comparing all pairs. Okay, so find duplicates. If I take the quadratic time complexity of things, that has like the code in action, or code will be like this. First of all, it assign a variable of empty list, and then it runs a for loop for over the list, and for every element, let's say I, then again it runs a for loop to match the second item of the list, and then it compares for that element I and that element j is equal to, if it is same, then it detects the duplicates, then it append the list, this duplicates list, and then finally it returns the duplicates. That's how find duplicates works in that case. And the time complexity of that is quadratic. That is quite expensive. That is huge expensive. Let's say if the list contain of two elements, then um, it operates 4 times, and then if it is 3 elements, then it has to operate 9 times. So this is very very expensive. And next there is exponential time, quadratic time. Okay, find duplicates, duplicates. Okay. Okay, then exponential time. This is exponential time, 2 of 2 power of n. So it is recursive algorithms without memorization. It is very slow, avoid if possible. Okay, we can see there is a function Fibonacci of n, and then first of all it compares n is less than equal to 1. If it is less than equal 1, then it pass the n, return the n. Otherwise it return Fibonacci of n minus 1 plus Fibonacci of n minus 2. This is very slow. Okay, that means recursive. It always like it nested over the function. Inside the function again it uses this function. So it is very complex. Therefore next is space complexity, and that is space complexity describe how much memory an algorithm uses. Okay, how much space it takes. So first find max. Okay, and that is first of all 0 of n, that means constant space, only one variable. That means always whatever the list size will be, it always take the same space of space. Okay, and okay, and then this is the constant space, and 0 of n, that means linear space, that is like double list. It creates new list for size of n. So there is like double list. It takes the list and return x multiplication of 2 for x in a list. That means it runs a for loop and it iterate over the whole list, and for every item of the list it multiply by 2, and then make it a list and then return it. So you have to like, as it iterate over all full list, so the linear space, it will be linear space. That means increasing the list size, it increase the space as well accordingly. So this is the linear space. So I can see there is a practical example. Example 1 is list operation. Let's see. So first one is constant time. I already see that, and then linear time again. This is a sum function, that is built-in function, but it take linear time, because when the list is grows, then it takes the more runtime. because it iterate over the whole list, and that's why it takes the linear time, and then the linear time again. Okay, and the linear time. Okay, my list append 6, so usually 0, yeah, 0 1, but can be 0 of any list needs to resize, so that's the case. Must shift all elements. Insert function must shift all elements, because it insert a value in a particular portion, particular index. So let's say here is a here it insert 0 into the 0 of index. So if there are another values like the previous values, what is in the 0, what is in the 0 index, it has to go to the index of 1. Then what was index of 1, that is goes to index of 2. So that's why every element has to shift their shift, so that's why it is linear time. And then I can see example 2, that is dictionary versus list lookup. Okay, so there is a list, my list, and if 3 in my list, that means for that comparison, it iterate over all the list, all element of the list, to see or to find the tree, right? So that's why it is 0 of n, that means linear. And then it print found. Okay, fine. And dictionary lookup, that is 0 of 1, because dictionary contains two things, key and value pair, right? So and key will always be unique. There are no possible to duplicate key. That's why if I found anything from the dictionary, it is just only one, 0 of 1, 0 of 1 time complexity. That means constant time complexity, always take the same time. And there is optimizing code, example 3, that is inefficient, that is okay, this is the example of optimizing code. Let's see. First one is inefficient, that uses quadratic, n number of 2, n power of 2 time, has duplicate in inefficient way, that takes the list, and then it runs nested loop to found the duplicate, which is I seen before. First for loop there is a I, and second for loop there is a j, and then it compared I and j. If it match, then it return the true, otherwise it false. That's it. So it just check if there is any duplicate in the list. And the efficient way we use this 0 of n, that is linear. So first of all, it take a set that is called scene, and then just runs for loop for once, and for every item, if the item is in already the scene, that means there is a duplicate, and it returns immediately. That's it, nothing else. So that's why it is 0 of 1, that means always take the zero of the no, that's a linear things, like just how list grows, the runtime will grows accordingly in the same linear way. Okay, and we are last things, we are uh, almost complete the time complexity and space complexity. Time complexity in data science, understanding the time complexity is crucial when working with large data set. Yeah, of course. And zero of n is efficient way, that is a new column is equal to column 1 plus column 2, that vectorized operation. And zero of n square is inefficient way, like it it runs a for loop and take two things, index and row, and in eta rows, and then for every time df log index new column is equal to blah blah blah. Okay, we'll see in the next when I work with pandas and numpy in real data science. So I skip for that. I don't it don't need to understand right now, I think. And key takeaways for time complexity: choose the right data structure, list versus sets versus dictionaries. Okay, so choose the right data structure is a very important thing to like, in case we can we want to operate something very efficient way. Avoid nested loops that creates a n square. Okay, so this is very worst case scenario it creates. Use vectorized operation when numpy and pandas we will using. And profile your code, use time it or C profile to measure the actual performance. Okay, that's the good one, good tips. And understand trade-offs. Sometimes of n logarithm of n is acceptable for simplicity. So and it is very important to understand which one is should take in when. Sorry about that. Then we will understand or try to understand iterators and generators. What is this? What are iterables? An iterable is any object that can be looped over. Okay, that can be looped over, that is the iterables, like list, tuples, strings, dictionaries, all of these are iterables. What are iterators? An iterator is an object that implement the iterator protocol. Okay, what is this? This is the iterator protocol. It returns the iterator object, and next returns the next value, something like that. Let's see in the code in action, that is there is a list, and then it converted to iterator. Okay, iter function make this list to iterator, and then I can use nest function. Okay, that's good. Got it. Creating custom iterators, that is countdown. Let's say in the countdown we see like 5, then 4, then 3, then 2, like that. So it is also iterator, and for that initialize with a start and then self of current, because like start it can say 5 or 10, so it start from that. So self dot current is equal to start, and then it make the self is iterator. Okay, and then the next will be like self dot current. If self dot current is less than equal 0, then it raise a stop iteration. Okay, otherwise self dot current minus equal 1, that means deduct 1 from the current, and then it returns the self dot current plus 1. So if I try to understand about the function, like it uses the class 5, and then for num in counter it prints, and then it prints 5 4 3 2 1. Okay. So I try to understand this. So it passed the 5, so it the start value is 5, and then first of all current value is 5, and then what it does, first it going to be a iterator, it return iterator, and then after iterator it can use it can make a next. So in next what it does, first if the current is less than equal 0, then it raises stop iteration, otherwise it just detect one value from current. So first it comes 5, so first it minus 1, that means 4. After 4 it returns self current plus 1, that means its current value is 4, then plus 1 is equal to 5. Again current value is 4, and then it comes over again, and its value is now 4, then it going to be 3, and 3 plus 1 is equal to 4. Like that it runs the for loop, and when suppose like it is 1, when the value of current is 1, it come here, and first of all it minus the 1, that means 0, and return the value is equal to 1. And then the value is 0, so it's come over again, and it doesn't match, it matched that condition, because then current value is 0, that's all. And then it raised the stop iteration, that's it. And what is generator? Generator is a simple way to create iterators using functions. Okay, they use yield instead of return. Okay, it's kinda, I think, like a stream. Okay, so it's kinda a stream. Key benefits: what is the key benefits of the generator? Memory efficient, because it is lazy evaluation, and can represent infinite sequences, because it's lazy evaluation. Okay, so cleaner code than custom iterators. Okay, fine, let's see in the code in action. Squares of list, it takes the n, and first of all it assign a empty list that is called result, and for I in range of n. Okay, so result dot append by every like every element of up to n in a square in power to power 2, and then finally it return the result. This is the regular function. Okay, so this is the regular way of doing this, but in a lazy evaluation how it does. for I in range of n, yield, just yield I power 2. That's it. Nothing else. That's it. So if I compare the memory usage, first least square is taking all, stores all 1000 values, okay, because it has to append the list, then it has to return the list. So that's why it memorize all or up to range of n, it all values have to be memorized. But in the generator functions, it doesn't need store anything yet, because it just get one value and pass it, one value and pass it, one value and pass it. It doesn't need to store anything. So this is why it is called memory efficient. And then generator expression, list comprehension. Agar squares list is equal to, okay, creates list immediately, okay, create list immediately, and generator is creates generator, okay, square gen for x in range 10, okay. Then memory efficient, sum of square gen, generator compares values as needed. Okay. And then practical examples. First example 1 is reading large files. So inefficient way, with open file and reading mode. In the reading mode has f and f read of lines, so it loads all lines at once, okay. But if I use generator function, then first it opens, okay, fine, and then for line in f, for every line it runs the for loop and yield every line strip, yields one time at a time, okay. So it yields is one time, return one time at a time, and in this case, in this scenario, it returns full it returns full list. So process large file without loading into memory, okay. This is the this is where we have to use generator instead of this. Example 2, infinite sequences. Generator for infinite Fibonacci sequence. So a and b is equal to 0 and 1, while true, yield a. That's it. Then again, after yielding a and b, assign a new value. A will be b and b will be a plus b. That's it. So it runs over and over and over and again. So each generator won't run forever unless you break, okay. So this is the Fibonacci function. And for I num enumerate, so first of all it has to make it enumerate, and then if I is going to be like 10 less than greater than equal 10, then it should be break. That's it. Then print, after printing I can see something like that, 1 1 0 1 1 2 3 5 8. That's it. So okay, generator best practice. Okay, let's see example 3, processing large data set. Process in chunks, okay. Data, then chunk size of 1000 for I in range 0, length data will be range of 0, length of data, chunk size, okay. Yield data I থেকে I plus chunk size. Process large dataset in chunks. Okay. mm, mm, List chunk size. mm, 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 mm. Okay. Range of 10 lakh. 10 lakh, make it a list, and that is a large data set. And then for chunk in process in chunk, it pass the large data set chunk size 10,000, and then process chunk, process the 10k items at a time. Pipeline processing, read numbers file name. Okay, yield. So filter even numbers for numbers to yield num. So okay, define a square and square numbers for num in numbers yield number power 2. Okay, this is going to be okay. This is the that it makes a square list. Okay. Generator versus iterator. Generator function simpler. Count up to max. Okay, so count 1 while count is less than equal max, then it will yield count and count. Then after yielding, count will increase by 1. And custom iterator, more verbose, and counter up to, and it is going to be, first of all you have to init the max. Silver max is equal to max, and count will be 1. Iterator, and then make the self is iterator. Make it after it use the next function, and that does if self.count greater than self.max, then stop iteration. Otherwise current will be self.count and self.count is +1, and then finally return the current. Okay, after example, seeing the all of examples, we have to know when to use generator. Use generator when working with large data set, processing data in streams. I said it before, like it's like a streams. So creating infinite sequence memory is a concern. You want to lazy evaluation, and use list when you need random access, like indexing, and you need to iterate multiple times, and data set is small, so you need list method like append, extend, etc. Then we has to use list, otherwise we will use generator for more memory efficiency. Okay, generator best practices. Okay, and process large file name. First of all we have to read the file, and then yield every line. Okay, then generator are memory efficient, process data one time at a time. Yes, use yield for generator. Creator generator automatically creates. Okay, generator expressions are concise, very short context expression. Okay, perfect for large data set. Yeah, don't load everything into memory, so that's why it is perfect for large data set, and can represent infinite sequence. Yeah, useful for streaming data. And chain generator, create processing pipelines. Okay, so that's it for today. Tomorrow inshallah we will start GUI development with Tkinter or Kinter. I think it's Kinter. Okay, so we will do that. Yes, sorry, we will do that tomorrow, inshallah. Till then, till then, mm, till then, bye. Good night. It's not good night. Anyway.